Okay, let's dive into this explainer. Picture this. Your SQL query looks absolutely fine. I mean, the syntax is flawless, the logic completely makes sense, but the moment it hits production, the database is suddenly on fire. The server locks up, CPUs spike, and literally everyone is panicking. Why does this happen? Well, today we're going to learn exactly how to use MySQL Workbench to pinpoint why a seemingly innocent query is acting like a database assassin, and how you can track down the root cause with absolute surgical precision. You know that classic joke where a ghost pops out, yells boo, and the developer doesn't even flinch? But then the ghost leans in and whispers, "full table scan?" And pure, unadulterated panic ensues. That full table scan, that is our main villain today. It's the silent killer of application performance, and our goal is to basically become the Ghostbusters that hunt it down. We're going to frame our entire investigation around a classic, panic-inducing support ticket that I am sure many of you have seen before. It goes something like, the reports page takes 45 seconds to load. Fix it. It's vague, it's urgent, and it's absolutely ruining someone's day. As a support engineer, when you get a ticket like this, you have to ground the problem in reality immediately. Now, remember, as a support engineer, your job isn't necessarily to rebuild the database schema from scratch or rewrite the entire application's back end. Your job is to surgically prove exactly where the system is breaking so the development team can fix it without any guesswork. You need undeniable evidence. You have to bridge that gap between, hey, the app is slow, and this exact query is missing an index on this exact table. To get that undeniable evidence, we use our ultimate magnifying glass, the explain command. Think of explain as a window directly into MySQL's internal decision-making process. When you put the word explain in front of your query, MySQL doesn't actually run it to fetch data. Instead, it hands over its battle plan. It tells you exactly how it intends to retrieve your data, from which indexes it plans to use, right down to which tables it's going to scan first. Now, raw, tabular, explain output is dense, it's cryptic, and honestly, it's pretty exhausting to read when you're dealing with complex joins. But MySQL Workbench has this incredible visual explain feature. It translates all that academic, JSON-heavy SQL data into a highly readable, color-coded flowchart. It makes spotting the bottleneck a massive relief, literally turning an hours-long hunt into a nearly instantaneous discovery. But before we get into the flowcharts, there are 4 crucial clues in the explain output you absolutely have to memorize. First is type. Think of this as your query's speed limit. Next is key, the actual index MySQL chose to use. Then rows, which is MySQL's best guess at how much data it has to sift through. And finally, extra. This is where the hidden killers hide, things like using file sort or using temporary. Let's zero in on that type column for a second, because it is your biggest indicator of health. If you see type all, that is your absolute worst-case scenario. It means MySQL is performing a full table scan, literally looking at every single row in the table to find a match. On the flip side, type ref or type EQ_ref are massive green flags. They mean MySQL is efficiently using an index to jump straight to the exact data it needs. When you open up Visual Explain, treat it like a map. You read it bottom to top, left to right. And your main goal? Hunt for the red nodes. Red means danger. Once you spot one, you check those row estimates and see if the key is missing. So the trick here is leaning heavily into this color-coded visual language. Blue is optimal. That's a unique lookup. Green is good, a solid index lookup. Orange is medium, usually an index range scan. But red is bad. Red means full table scan. By simply glancing at these colors, you can spot performance bottlenecks in a fraction of a second. Section 1. The Sequela Scenario, investigating the 45-second load time. Let's put all this into practice with our real-world ticket, that agonizing 45-second load time on the reports page. We grab the slow query, paste it into MySQL Workbench using the Sequela sample database, and hit Visual Explain. Right away, a terrifying number jumps out at us: 10 million. MySQL estimates it has to scan 10 million rows just to generate one single report. Let's review the crime scene evidence here. Execution time, 45 seconds. Access type, all, perfectly confirming our full table scan suspicion. The key is null, meaning absolutely no index was used. And over in the extra column, we see using file sort, which means heavy, CPU-crushing sorting work is happening behind the scenes. And the visual diagram makes the culprit completely undeniable. You really don't have to be a database architect to spot that giant, glaring red node labeled all. It visually screams that the database is doing way too much work. It's exactly like searching a massive warehouse for a specific item, but instead of just checking the registry, you're physically opening every single box. So, what's the fix? The solution here is straightforward but incredibly powerful. By looking at the query attached to that red node, we can identify the exact column being filtered in the where clause. We then simply add an index to that specific column. That index acts like a table of contents for our warehouse, allowing MySQL to jump directly to the exact boxes it needs without checking all the rest. The transformation is honestly staggering. Before we added the index, the query took 45 seconds, performed a type all scan, and chewed through 10 million rows. After applying the targeted index, the execution time plummets to 0.01 seconds. The access type changes to ref, and it only has to examine 2 rows. That is the magic of properly reading an explain plan. When we rerun Visual Explain, we get immediate visual validation. That terrifying red node completely disappears, and it's replaced by a reassuring, beautiful blue node labeled ref. The database is saved, the CPU spikes drop, and the application becomes instantly responsive again. We didn't guess, we proved the fix worked before it even hit production. So how do we package all this up? Well, as a support engineer, you can now craft the perfect handoff ticket for the dev team. You include the exact slow SQL query. You attach a screenshot of that red visual explain node so they can literally see the problem. You identify the bottleneck as a full table scan, and you recommend adding an index to the specific column. It is undeniable, actionable proof. Which brings us to the end of our explainer today, but I want to leave you with a slightly terrifying thought. On a large production table, even one single unindexed query can completely lock up a server under load. So ask yourself, if one query can do that much damage, how many hidden full table scans are lurking in your database right now? Don't wait for the server to crash. Open up MySQL Workbench, run explain, and start hunting those red nodes today.